Welcome to High Output, the podcast exploring how today's engineering leaders are building tomorrow's high-performing teams. I'm your host, William Chang, and each episode, we sit down with visionary engineering leaders who are forging new paths in a rapidly evolving field. Join us as we gain a window into tomorrow's software organizations and discover what's next for our profession and the entire software industry. This episode is brought to you by Maestro AI. Engineering leaders, let's be real, understanding how your team is doing has never been more challenging, especially during this era of AI-powered transformation. You're trying to ship faster, keep your team healthy, and communicate value to stakeholders. That's where Maestro comes in. Maestro is an engineering visibility platform that marries smart metrics with narrative context. It enables you to understand everything that's happening in order to improve velocity, understand individual and team output, and make better decisions faster. Visit getmaestro.ai for more info, because you don't know everything, but Maestro does. All right, I'm super excited to welcome my guest today, Sylvain Kalache. Sylvain has a unique career trajectory that spans deep technical engineering, education, and entrepreneurship. He is currently the head of AI labs at Rootly, the AI-powered incident response platform trusted by companies like NVIDIA and Dropbox. There, he leads the charge on developing AI-centric prototypes and open-source tools to advance reliability standards. Before Rootly, Sylvain co-founded the Holberton School, a global engineering education company that's trained thousands of engineers for top tech firms like Apple, Tesla, and NASA. He also brings deep roots in site reliability engineering, having built massive scale infrastructure at LinkedIn and SlideShare, where he even patented a machine learning powered self-healing system. Sylvain, welcome to the show.
Thank you for having me, William.
Yeah, well, let's jump right into it. Please tell me if I missed any gaps in your history. Tell us about yourself.
Yeah, so was born, grew up in France, started my career building clouds when public cloud was not a thing. So I started with private clouds, like crawling in data center floors, passing cables. I was studying computer science at the time, master, did a year in China, and then finished my master in computer science in San Francisco, where I started my career full time. As you mentioned, I joined SlideShare as a DevOps practitioner / SRE. The SRE practice was emerging at the time. We got acquired by LinkedIn, where I worked there for over 3 years as a senior SRE. And with all my experience, as an engineer trying to hire talent, and I created a bunch of software communities, I learned one thing, that there is a lack of technical talent pretty much all over the world. So decided to take a stab at this problem, created a startup that became this very large company, Holberton School, with schools, I think now in like over 25 countries, where we train people with a very different methodology. We had no teacher, no lectures. You would learn by doing. And then after that, I did a bunch of consulting, was a developer relation as a consultant for startup. And as you mentioned, joined Rootly about a year ago. We are an on-call incident management platform. We also now have an AI SRE, which we might speak about later today during this episode. And at Rootly, I have a very cool position. I'm in charge of basically exploring what AI can bring to the world of reliability. So it's kind of a constant hackathon. We work with fellows who are we have a bunch of students. We have also people who've been in the industry for a while, like the head of platform engineering at Weight and Biases. We have the former head of AI product at Twilio. And we just try the latest model, tool, framework, whatever, is coming. There is constant flow nowadays. And most of it doesn't stick. We build a prototype, show it to the community, and we're like, yeah, cool, but maybe not that useful. And then for some other project, the community likes them, and so we maintain them. We have a bunch of them. I'm going to share just two very briefly. One of them is called SRE Skill Bench, and the goal is to test LLM capabilities for SRE type tasks. So think of it as Bench, but for SRE. Another one is called On-Call Health, where we help engineering team understand if there is something wrong with their on-call and maybe their engineer are overworked. Yeah, that's me in a nutshell.
Fantastic, fantastic. So let's back up a little bit and start with the basics. What exactly is an SRE and how is it changing? How is that role changing?
Yeah, so the SRE practice was invented by Google over 10 years ago. I want to say 15 years ago. So it's been a while. Now it's quite an established practice. And the nutshell, I don't know how much you want to get into the definition, but an SRE is basically, SRE stands for Site Reliability Engineer. And it's pretty much a software engineer whose job is to keep system reliable, scalable, and efficient using code and automation instead of manual ops work. So yeah, that's what SRE is in a nutshell. And I think obviously reliability is kind of the core concept for this practice. And we use metric like SLO, SLIs, error budget, MTTR to kind of measure how this team are doing, and that's kind of like the North Star for them. And yeah, I think it's now becoming like a practice that's widely used by company, especially I would not say for young or small companies, but as you grow and you scale your business, generally that's when this type of engineer start to join your engineering team.
Yeah, yeah. Well, thanks for that background. So now, how's that changing? You mentioned that Rootly, you guys are building an AI-based SRE. There's a lot of code now that's created by LLMs, and that must affect reliability somehow. Can you talk about some of the top trends that you're seeing?
Yeah. So yeah, I had the chance to actually give a talk on that at the last SRECon. And so when I prepared the talk, my assumption was, as you described, like, hey, like, how is Gen AI kind of impacting reliability and SRE more specifically? As you said, like Gen AI is impacting the velocity of engineering team, the volume of code that's being produced. And I think there is a lot of conversation about this. I don't think we need to cover this topic, but we don't speak a lot about what's happening once this code is written and needs to be maintained in production at scale. And so I took a very very engineer approach to tackling the topic. I came up with a rough formula of incident rate, which is, as I mentioned, one of kind of the metrics that SRE look at, and kind of deconstructed this incident rate into kind of two main numbers. The first one is the volume, basically the number of times that a system change. And as you just mentioned, there's a lot of code being shipped, so this number has been increasing a lot. And then the other number, which we can call P, we'll say that the first number is V and second number is P, is the probability that one of these chain is a breaking change, right? And so when you think about the volume, because it's increasing, the formula, right, like the incident rate will like drastically grow. That's actually the theory on paper. And so for SRE, it means that potentially they will have to deal with like a very large volume of incident. And I think that's not just the volume of incident that potentially could change, but also how much help they have during an incident. So let's say that production is down. Let's do role play. Let's say I'm the SRE and William, you are the developer. And something broke. I will do a git blame on the microservice and find that you worked on it. And I'll be like, hey, William, how about you come, sit next to me, or let's jump in a Slack channel because I can't find the issue. You wrote that. Maybe you can help me solve it, right? Most of the time, like developer comes in and help and will potentially drastically speed up the speed of debugging. But now with Gen AI, you actually may not know what you wrote because you prompted an AI assistant to do it, right?
Mm-hmm.
but you may not know actually what's written. So, potentially more incident and also less help when you have to troubleshoot something. Yeah, so I think that's a first kind of, at least theory. I'm not saying this is happening, but that's kind of, what we might envision that might be happening for engineering team.
Yeah, it's actually super interesting because if you're an engineering leader, you're a VP of engineering or something, one of your big goals is increased velocity, right? Like you want to push more volume out. You want to get through your backlog faster, roadmap faster. But now that's at the consequence possibly. There's a bit of risk there. The generative AI is kind of making reliability possibly worse.
Possibly, yeah.
Do you think that's true or not? Is it actually, are you seeing that there's this backlog of reliability issues that we're going to have to pay for later? Or do you think that that won't be the case for some reason?
So, when I got this talk in, I was like, sweet, I'm gonna be able to, look at this AI slop and have a bunch of fun
Mm-hmm.
seeing how LLM is failing us in Gen AI more specifically. The term AI slop is a thing. Like here, I'm not speaking about, goofy picture, but AI slop for coding. And I did found a
Mm-hmm.
bunch of things. One of them was that, for instance, if you ask your coding assistant to write, let's say, a unit test for a code it wrote, it will write the unit test replicating the already broken code. So,
Mm-hmm.
ain't working on paper, but the test is working fine. Another issue is that it's not really testing intent. It's writing a unit test, but it's superficial, right? It doesn't really test the actual intent of the code. Another one is something new that's called splop squatting. And splop squatting is basically sometimes GenAI will hallucinate packages, library
Mm-hmm.
packages. And what attackers do is that they actually take this package's name and will provide the code, but will inject some malicious code inside, right? So,
Right. Right.
so when the malicious code is in, then you are pretty much screwed. And company did an experiment. They surfed on that, and the library I think was downloaded 10,000 times in a matter of like 3 months. Mentioned in a bunch of README pages on GitHub, so it's really working. So yeah, so I found some stuff, but then as I was sharing this with a friend of mine who is an SRE leader at Airbnb, it was like we were having fun, surfing on this, and it was like, boy, like I'm pretty sure that humans do the same type of mistake. So,
That's true. I mean,
right,
people mess up too, right?
people mess up. So I was like, okay, you know what? Let me try. So for split squatting, which is pretty much like blindly accepted, like accepting some library. We've kind of been doing this with like the classic curl, some bash script into pipe bash, right? Without looking into it. And even though we have a lot of package manager, it's still happening. Look, for instance, Docker, like recommended installation methodologies using this, script. The other thing that may, or the fact that AI hallucinates, and actually there is a good story where AI hallucinated and by mistake deleted someone entire files. We've been doing rm-rf slash right, right, by mistake using
Mm-hmm.
root. Another one is on the same thing of distraction. Some researcher proved that if you give the LLM a problem statement, whatever it is, and at the end you put a sentence like "cats sleep for most of their life." You have like, let's say, hey, you should develop this feature, and you put this random statement about cats in your prompt. The LLM was, I think, 40% less likely to solve the task correctly. So they get distracted. And as you know, humans also get distracted. Cats are the most important thing on the internet, right? So I think, like LLMs are there. And this talk was like months ago. I think things change a lot since then, this issue might not be relevant. But where I'm driving my point is that the way that LLMs are failing is also stuff we've been doing, for the longest time as humans.
Yeah, yeah, yeah. Are there, the one thing we hear on the AI coding side of things is that LLMs, Gen AI can fail in a very similar way to humans, but there's also unique ways that they fail, right? Like the unit test example is one that's super interesting because as a human, if you're really lazy, I guess you could do that, right? You're like, I wrote my code, I'm just going to write a test that makes sure that it always works. I'm not doubting that. But it feels like LLMs, like it's just more possible than a human who generally likes their job or something, is trying to work hard at their job. Like that's almost like a class of problems that's more prevalent in LLMs versus people. Do you see things that way? Like, do you think there are different classes of these problems where LLMs might have new failure cases that you need to check for? Or do you think it is like, it's just like humans, but if you had a lot of humans, you would also have a lot of problems?
Yeah, you know what? I was really trying hard to find new failure cases. To be honest, I didn't find them, which was a bummer because
Mm,
my entire talk was about that. I think what you described is absolutely true, but I'm not sure if the issue is the LLM or the prompt. And
mm,
I think
mm.
the beauty and the curse of LLM is that whatever prompt you give them, it's gonna work, right? The LLM is
Yeah, it's
gonna
going to give you something.
exactly right. But then there is an ocean between a good prompt and a bad prompt, right? And where you have all these prompting techniques, which are, it can be like drastically actually efficient. I'm getting back to one of the project SRE skill bench where we test LLMs against SRE tasks. We partner with a company that's called Not Diamond, and what they do is prompt optimization. And we found that by doing prompt optimization, we could double the efficiency of some of the model, especially for anthropic model, which compared to OpenAI, so which would lead me to think that anthropic model will be like much more sensitive to prompt and will really kind of try to respect what the prompt is about. So if your prompt is not super detailed, it's not going to work as well that if you are like super accurate. So yeah, I haven't found like really like very new failure class that make this super original. And I think in some shape or form it's very similar to what we've been doing as humans.
Hmm. What about the volume thing? Going back to that, right? So, if let's say a company used to have 50 engineers, right? And now it's 50 engineers worth of human errors versus now let's say each of those 50 runs 10 agents or something. I'm just making it up, right? Now you have like 500 agents worth of errors. So, do you see that volume being an issue here, or do you think it's handleable? It's solvable problem.
Yeah. So I think my opinion, the way I approach to answer this question, because I wanted to answer that specific question for the talk, is again going back to this formula. The incident
Yeah,
rate
yeah.
is V times P, right? I will repeat very briefly. V is the volume of changing, how many changes per unit of time, and P is the probability that one of these change is breaking.
Hmm.
Like V, as you say, is like increasing like drastically. So the incident rate has to increase, right? And so I think in some ways, the fundamentals, all this, as I say, like the goal of an SRE is to maintain reliability, and you need to use automation and code to do that. So there's a bunch of guardrails that SRE put in place to ensure that. And so these guardrails are becoming more important than ever.
Hmm.
And I think AI is, I don't know if it's screwing more or less than us, but it's doing it at least 10 times faster, right?
That's true. Yeah.
So, most of the time might be right, but also, as you said, because the volume is greater, like eventually you are going to introduce more issues. So I think for reliability teams, their work is not becoming obsolete, but more important than ever. Things like code quality, test coverage, deployment process, observability, overall operational hygiene, with like infrastructure as code, automation, alerting, resilience and capacity type of thing, like load test, chaos testing, All of these things that, we've been doing for like 10, 15 years are becoming more and more important. And maybe also, I would say, needs to evolve. And my theory is that what is causing the issue in the first place, Gen AI, could potentially help this practitioner to handle the issue.
Hmm. Even in your previous example of taking the engineer who wrote the code and sitting down with them on Slack or in a meeting, it's possible that you could run an LLM against those code diffs and try to see, oh, hey, this is behavior I'm seeing. This is the code. Can you help me find a cause? So it seems like the same thing that might have gotten us into the pickle, can help us solve it.
Yeah, you are like, it's exactly what's happening. And so there is a new type of tool that's emerging that's called AI SRE. Now I know a lot of people don't like the word AI SRE because it's controversial. But anyway, the point of this tool for now is exactly what you described. You plug this into any tool that has context. Could be your Slack, could be your knowledge base, could be your incident management. So you have access to all the incident and postmortems. Could be your Git, observability tool, alerting, traces, all of that. So that it's in two steps. Like, not only this tool can kind of proactively learn about your infrastructure and kind of develop this instinct or intuition that SRE have. What I mean by that is that when you are a good SRE, we've been at the company for quite a while. When something breaks, you kind of know where to look, and you kind of know that, oh, this microservice, oftentimes it's because of XYZ database, or maybe it's something upstream or whatnot, right? You have this intuition and you kind of know where to look. So this tool has the ability of developing the same kind of intuition, so that when an alert comes in, they will like develop a plan and then start to troubleshoot on their own.
Yeah, yeah. And, at Rootly, you guys are building an AI SRE, right? Like, have you seen I guess, how successful is it? Yeah, it sounds good in theory. It sounds absolutely doable. I mean, what are you seeing when people actually use this?
Yeah, it's impressive. One of the main reasons why I joined Rootly is because I think, as you mentioned in the intro, over 10 years ago when I was at LinkedIn, I was very annoyed with repetitive work on incident and all of this. And I was like, boy, like, we have like all these signals, all these logs, all this data that we should be able to learn from that and correlate. And so we can increase time to resolution and solve automation. So I wrote a concept that was self-healing, and ultimately became this patent that was not really my goal, but my company was like, hey, we need to patent stuff. So this is what I did. Back then, machine learning was nearly not as good and very hard to use. It was a prototype. I never got a chance to build it, and then I created my company. But now this is happening. And to answer your question, in terms of what we are seeing, it's quite impressive. The first thing, even if we don't speak about really like let's say like the LLM trying to solve the problem, the fact
Hmm.
that this tool can collect all this data for you in a matter of a few minutes and bring all of this context in one Windows is super useful, right?
Hmm.
Before you have to go, let's say, to Checkly, to Chronosphere, right, to your Prometheus and Grafana, and you need to, in a clock like which group and aggregate all the graph. Takes a ton of time, right? Now this tool is doing this for you. And then, of course, the second part, which is the most interesting, is then throwing all of this to an LLM and trying to have it find the needle in the haystack, and it's working. So now it's working for like, save 3, save 2, maybe save 1. And I mean, the severity is not that always, maybe that's not the right format. But what I mean by this is that for simple incidents, we are seeing customer where the incidents are no longer handled by humans. There is there is an alert, and the AI Siri look at the alert, see it's an incident, go ahead, look at it, investigate, fix it. Now, like for distributed, architecture that are complex, it's not there yet. And I don't know how long it's going
Hmm.
to take here to solve that. But we are, at the very least, for this complex incident, I think it's good to kickstart your investigation, get some
Hmm.
context going, right? And then the human can take over.
Yeah, yeah. And back to your point, I mean, it seems like even in cases where you can have an AI SRE, take care of the incident end to end, at the end of the day, if you're using more Gen AI code, you might have more of these incidents. And so you still need people to oversee the process. You still need a team. It's the SREs themselves are not going to be put out of business, even if an AI SRE gets pretty good.
You are dead on right. Like I think, and I think this is like overall for all engineer. It's not like the job is going away; it's evolving. And you've been long enough in the industry, and I'm sure many of your listeners have been long enough in the industry to know that, right? Like every time there is this like massive gap in our world, we're like, oh yeah, I'm gonna lose my job. And yeah, I mean, some jobs are disappearing, but new ones are creating. And I think for like software engineer or SREs, their job is gonna to orchestrate flows, right? Where we're gonna
Mhm.
put AI at work, and as you said, orchestrate and supervise. And we need to improve this flow, and sometimes this flow won't work, and we need to either improve it or dive in. But yeah, and I think we are gonna eliminate a lot of repetitive work. Look, no one likes incident. No, I mean, actually, some people like incident. I do like the thrill of incident. I don't like doing them at night, or during
Hmm.
private time or thing like this. But joke apart, like I think a lot of people. It's very stressful. It can be very bad for the company, for the brand, or financial or customer, right? So I think that's definitely something we want to solve, and not, hey, let's keep this problem for humans.
Yeah, yeah. Building on that a little bit, in some ways, when a person wrote the code, the general practice is say, hey, let's be blameless about the cause of this. Let's just try to figure it out. And, honestly, but there is a little bit of a blame thing, like what areas are more problematic? Where should we focus more attention? If Gen AI is writing more of this code, and then you even have AI SREs kind of, like who's to blame? Is there, should we blame the LLM now? Or, do you think that that blameless culture carries on in the future?
Love that question. I'm going to answer this. First of all, I just want to also touch on another point where a lot of people, especially SRE, and for good reason, are like, I'm not touching this. I'm not touching systems that are non-deterministic. Absolutely against everything I've been doing, right? We are trying to build as deterministic system as possible, right? Like that's the goal. And now you are telling me to use this like, dream machine, but but joke apart, like I think you are totally right. Like we've been pushing for this blameless culture, and for humans, and humans are unpredictable. We are non-deterministic, right? And so we've been building this system, right? This guardrail I've been speaking about to ensure that we catch these issues that are brought by this non-deterministic stuff that are humans, right? And as we discussed earlier in the call, it's pretty much similar to LLMs. So the first thing I want to challenge, if some listener here are skeptical about, letting LLM do their stuff, is that we've already been doing this with human, right? So it's just about having this guardrails that will let LLM do stuff, but also it's trust but verify, right? And make sure that whatever they do is fine. That's the first thing. In terms of the second part of your question, I think this one is truly very interesting. There is a consultancy firm that did a surveyed like an engineer from a bank, and they were asking them about, hey, how do you feel about this incident and these outages that were caused by them? But what the engineer was saying was like, hey, it's not my fault. Like Gen AI wrote that. So I don't know. That's one anecdote. That's just one employee, from one company. But if this person thinks this, that probably other people are thinking that. So I think to your point,
Mm-hmm.
there is a lack, like there is an erosion of the ownership of the code base, which I think is totally wrong.
Mm.
And I think engineers need to start thinking more as SREs. I think like it's not because your tool is deterministic that you should blindly trusted. So in my opinion, there should be like a kind of a like shared responsibility. Of course, SRE will do their best, but I think engineer should also do that. And I think there are new tools actually to do this. Let's say an engineer developer write their code. How about using another model to judge your code, right? Right. That could be like a good practice to do. And there are other practices that are emerging, like mutation testing, right? This practice has been around for a while, not super successful, but the beauty of LLM is that now you can, throw this massive kind of brain at it. Facebook has actually shared some work on this, where they tried a tool on the Facebook, Instagram, and WhatsApp code base, and they were able to generate roughly 10,000 mutants with about, I think, like 500 like test cases, privacy hardening test cases, and 75% of these tests were approved by engineers. So, I think there are like ways for our industry to become better and really invest in reliability that at the end of the day might equalize, like we spoke about how this volume of code is increasing, and so number of incidents might increase, but I think it might equalize, or even we might end up having a better reliability at the end of the day.
Yeah. That makes sense. So if you were to look forward now, we're at this point now where AI coding agents are, they're getting pretty good. AI SREs are getting pretty good. If you look forward a few years, where do you think the industry's at?
Yeah, so I think your audience is mostly engineers, right? Engineering leaders. Whether you like it or not, agentic coding is here to stay. It's not going away. And what I see is that I think the work of engineer is shifting, and it's like kind of we are all becoming managers in some ways, or maybe not manager, but like team lead or tech leads, right? And we are instructing, it's like you would instruct your team and lead them into building something great with the best engineering practices and whatnot. And so that's who you are becoming. You are leading these agents. They can do great stuff, but you need to lead them. You need to instruct them properly. You need to have the right guardrail in place. So that's one thing I'm seeing, and where I think the industry is going is we're moving away from the like manual work of typing lines of code to directing. And the second one is I think engineer will have an increasingly more important role to play in how the product is shaped, and have like having, I think, a product intuition will be important. Let me explain what I mean by that. Like today, before, Gen AI, like kind of the regular stuff would be a product and design would design, right? The thing, pass it to engineer, and then you have the spec and you respect, right? Today, all of this timeline is compressed. And so if you use, let's say, like, Vercel V0 or just Cloud Code, you can come up with like a product feature very quickly, and you can be in charge of the UX and the UI and the design very easily. And so I think there will be more and more, I believe that engineers will be more and more sensitive to this. I think their job is basically becoming more and more closer to the business and further away from the craft of coding.
Yeah. Well, thank you so much, Sylvain. You walked us through so many cool topics, from the SRE practice of the past to the current to the future. Really, really appreciate the conversation.
Thank you, William. Thank you for having me.
Thanks for tuning into this episode of High Output. If today's conversation was useful, please take a moment to subscribe wherever you get your podcasts. Engineering leadership is evolving rapidly, and we're committed to bringing you insights from the front lines every week. Visit getmaestro.ai/high-output for show notes, transcripts, and past episodes. Until next time, I'm William Chang, and this has been High Output, where we explore how today's engineering leaders are building tomorrow's high-performing teams.